Thanks for joining me. In this video, we will be discussing quadratic function applications. So we'll have 3 examples and we will talk about how to work our way through these. Now these were taken from My Open Math. To give credit where credit's due, here are the authors of the problems that I'm using. So thank you for providing those in My Open Math. So these are just screenshots of the homework problems that you have. I just picked 3. These 3 do not have a video accompanying them. Some of your other word problems will be similar, and some of your other word problems will have a video accompanying them already. So I figure there's no reason to make another video. But hopefully these will help you get started on some of the ones that are similar to these. So question 1, the cost formula for a company can be modeled by C equals, and because the variable is X, you will often see this like this, C of X, same thing. Similarly, in the next sentence, you will see them talking about R, which is revenue, and that can also be called R of X because our revenue is a function of the variable X. So we have this cost function. So the C is the cost function and the R is the revenue function. So that's their income. X is the number of items sold. A company will break even when its cost equals its revenue. Its cost equals its income. So in this scenario, we have a cost function and we have a revenue function. So we can see how many items a company has to sell in order to break even by setting these 2 functions equal to each other. So the cost function is 1,386 plus 15x plus 0.2x squared. And I'm going to see when that is equal to the revenue function, 90x minus 0.8x squared. So this is a quadratic equation because I have x squares. So when you have a quadratic equation, remember that you want to get everything on one side of the equal sign and set it equal to 0 so that you have the option to try to factor or use the quadratic formula. So I'm going to add 0.8x squared to both sides because that will zero out the x squared. And then I want to move that 90x, so I'm going to subtract 90x from both sides. So on the right hand side, I'm going to get the 0 that I want. And on the left hand side, I'm going to rewrite it so that it's in descending order. So the x squared piece will be first. 0.2 plus 0.8 is 1, so 1x squared. 15x minus 90x is negative 75x. And then we have plus 1386 equals 0. And so now I can try to factor or I can do the quadratic formula. If you're not sure how this factors, maybe it would be easier to do the quadratic formula. I do happen to know how it factors, so I'm going to do it that way. X squared is x and x. This last sign, remember, is a plus, so that says we're going to have the same sign. And because this one is a minus, both signs are going to be negative, so minus, minus. And then 42 times 33 is equal to 1386. And if you add those 2 numbers together, you'll get the negative 75. So those are the factors. Then set each factor equal to 0 and solve. So x is 42 and x is 33. So those are the 2 answers that you'll get. And you'll see I actually left the answers up here. 33 and 42 are the 2 answers that I should have gotten, and I did. Okay, let's look at question number 4. So question number 4, it looks like I wrote all the answers. I left all the answers up, but that's okay. We'll show the work to know how to get there. So the cost in dollars to produce X designer dog leashes is given by this function C of X. And the price demand function in dollars per leash is P of X. Notice it's little p of X. So the price demand function is little p of X, and the profit function is usually given by a capital P. So again, this little p, lowercase p, is the price demand function, and the profit function is given by a capital P. So we can use the price demand function to find the revenue. So the revenue given by R of X is equal to X times the price demand function. So X times little p of X. So little p of X this time is 116 minus 3X. We can distribute the X, and we will get 116X minus 3X squared. So that's the revenue function. To find the profit, because that's what we're trying to find here, is the profit. Profit is equal to revenue minus cost. So however much you bring in is your revenue, and then that doesn't mean you profit all of that because you spent money making your product. So you subtract the cost. So revenue minus cost, whatever is left is how much you make. That's your profit. So we can find that. Okay, so revenue, the revenue function is 116X minus 3X squared minus the cost function is 8X plus 9. So make sure you put them in parentheses because it's going to be important that you distribute that minus, right, to each term of the cost. So this will be 116X minus 3X squared minus 8X minus 9. And so then when you rewrite this, combining like terms and put it in descending order, you'll have negative 3X squared, 116X minus 8X is plus 108X, and then the minus 9. And you can see that that is what they got right here. So there's the answer for the profit function. So whenever you're given the price demand function, you can use that to find the revenue. So that's kind of the first step. And then to find the profit, you subtract revenue minus cost. Okay, so let's look at the next part. Find the number of leashes, remember that's represented by X, which need to be sold to maximize profit. So when you're talking about maximizing or minimizing something, think about your quadratic function. So I'm going to erase the work I have here. If you needed that, you can rewind and pause and copy it down. So now I want to look at the maximum to maximize profit. So I'm going to look at the profit function, which is what I just found in the previous part, and I want to maximize that. So notice that this is a quadratic function. Also notice that the leading coefficient is negative. The degree is 2. That tells us that it's quadratic. Since the leading coefficient is negative, that means that your parabola is going to be going down. And so you can see that we have a maximum value up here. And if you remember, the value at the top, the very top, or the very bottom, depending on which way your parabola opens, is your maximum or minimum value. And that value is represented by what's called a vertex. So the ordered pair there is the vertex. So whenever you see maximize or minimize, they're wanting to know the value of the vertex of the quadratic function. So if you remember, the x value is found by using the formula negative b over 2a. Remember that a is in front of the x squared, so a is negative 3 in this case. B is in front of the x, so it's 108 in this case. And C is the constant. It's -9 in this case. And so if we plug that in, we will have -b, so -108, over 2 times a, which is -3. So that's going to be -108 over -6, and -108 divided by -6 is a +18. So that's where we get this 18 from. So the number of leashes which need to be sold is 18 leashes. Next is find the maximum profit. So the profit is the Y value. So to find the maximum profit, we're going to plug 18 in. So the Y value, this case Y is P of X, that's the profit. We're going to plug in our X value and see what we get. So -3x squared, so -3 times 18 squared, plus 108 times 18 minus 9. So that's going to give us -972 plus 1944 minus 9. And when I combine that together, I'm going to get $963. So that would be the maximum profit. By selling 18 leashes, we would make $963. And that's kind of best case scenario. Now you want to find the price to charge per leash to maximize the profit. So we already know in order to maximize the profit, we need to sell 18 leashes. Well, to find the price that you should charge, you're going to plug that into the little p of X function. So the little p, and instead of having X, I should put 18, because that's what I'm going to plug in. So it's going to be 116 minus 3 times 18. So that's going to be 116 minus 54, and that's going to be 62. So $62 is what you should charge per leash to maximize profit. So number 9. The unit cost in dollars to produce tubs of ice cream is $8, and the fixed cost is $6,336. They give us the price demand function. They want us to find the profit function, and then at what quantity is the smallest break-even point. So the first part, we've done this in a previous example, but we'll go ahead and do it again. And we also found the break-even point in the first example, but it's a little bit different in that we don't have the revenue and the cost given to us as directly, I guess. So let's just kind of look over this one and see how to do this one. So remember, to find the profit, we need to know the cost and the revenue. They give us the cost, but it's in a description. So here's the description. The unit cost is $8. So that is the unit cost, meaning it varies depending on how many units are produced. Fixed cost means no matter how many units you produce, you're going to have that cost. So a fixed cost, an example might be renting a building, right? It doesn't matter if you produce 1 tub of ice cream or 1,000,000 tubs of ice cream, the rent for the building is going to be the same. So that's a fixed cost. So when you're doing something like this and you have a variable cost and a fixed cost, you can usually represent that with a linear equation. And so that's what they're wanting you to do here. So y equals mx plus b. The slope, the m, is associated with the variable cost. The cost that varies depending on the number of units or the number of items. B is associated with the fixed cost. And so you would write this as y equals 8x plus 6336. And again, it's because the 8 is the variable amount and the 63.36 is the fixed amount. And then instead of y, since this is the cost function, you can rewrite it with the c of x. So there's the cost function. And then you need to know the revenue function so that we can subtract the cost from the revenue to get the profit. Remember that you can find the revenue by multiplying x times the price demand function. So x times the price demand function this time is 270 minus 2x. And we're just going to distribute the x. And we get 270x minus 2x squared. So that is the revenue function. And so finally, to find the profit, that is the revenue minus the cost. So that would be 270 minus 2x squared minus 8x plus 63.36. So that will be 270 minus 2x squared minus 8x minus 63.36. And then finally, we will have negative 2x squared plus 262x. Uh-oh, somewhere I lost an x. I'm supposed to have an x on the 270. So now 270x minus 8x is the 262x. And then minus the 63.36. And you can see that that is the answer that was provided, right, in the answer key. So that's correct, right there. That's what we were trying to find. And then it wants to know at what quantity is the smallest break-even point. So the break-even point is when revenue is equal to profit. I'm sorry, not profit. Revenue is equal to cost. So the break-even point is when revenue is equal to cost, or when the profit is 0. So if you're not making any profit, that's another way to look at the break-even point. So since we have the profit function, we know that's negative 2x squared plus 262x minus 63.36. We can just set that equal to 0 and solve. So if the profit is 0, then we'll have a break-even point. So when we solve this quadratic equation, the first thing I'm going to see is that I could divide everything by a negative 2. So if I divide both sides by negative 2, I will get x squared minus 131x plus 3168 is equal to 0. And now you can either factor this or you can use the quadratic formula. If you don't know how to factor it, go ahead and use the quadratic formula, or you can divide 3168 by numbers until you figure out what works. But it will factor. So x squared breaks up into x and x. The signs will be the same. They'll both be negative. 32 times 99 is 3168. And negative 32 plus negative 99 is negative 131. So that's how it will factor. And then solving, we will get 32 and 99. And so it asks for the smallest break-even point. And so that answer would be 32.